If your GPR has an accurate GPS, but what I mean by that is less than 1 meter of accuracy, you're working in an open area with lots of sky visible, another way to generate a depth slice is to collect a pseudo grid and use the GPS for positioning the GPR data. Basically, cover the area by walking back and forth with the GPR system to collect closely spaced lines, ideally the width of your GPR system. The data is then processed into depth slices on a PC. Here we see that somebody wandered back and forth around this field with zigzags and various line spacings. Here's the depth slice animation generated from the pseudo grid data. Rapidly slicing through the data reveals that there are 3 linear utilities that are the main features in this area. 2 of them are here. They're actually at different depths. You see one now, and now you see the deeper one now. And then over here, there appears to be one linear one running through there. So the other strong responses just are point targets. So as you can see, and maybe hear in my voice, I'm a big fan of depth slices. Whether they're generated from grid scans or pseudo grid scans, I love them. But there is a big but. Depth slices are powerful, but it is important to remember that depth slices are maps of target reflectivity at different depths in the subsurface. If hyperbolas are weak because they're from a non-metallic utility, have little contrast with the soil, or because the utility is close to the maximum depth of GPR penetration in the area, you may not see a linear target in the depth slice. These are the utilities that are often missed in GPR data. Increasing gain can help, but not always. Now, can you recognize this as a utility? This feature in here? If so, how confident would you be? So let's talk about increasing our confidence that a weak hyperbola is actually a utility. Here's an example of weak hyperbolas that are clearly visible to your eye, but are too weak to appear as a strong linear target in a depth slice. So how do we augment the depth slices to show these weaker hyperbolas? We do that by adding point interpretations to them. We take advantage of your eye's ability to see weak hyperbolas and we add points to them. In this example, I've added pink dots to the tops of the weak hyperbolas. If we were interpreting this depth slice, we would probably wonder if this faintly weak yellow area that's kind of linear is actually a utility. However, when we display the depth slice with point interpretations added, we see that this is a linear utility, a linear object, and our confidence that it's a utility has just increased dramatically. Once we plot the interpretation in a map view, we can see that many of the other hyperbolas we added interpretations to turn out to be just point objects in the ground. So adding interpretations is easily done right in the field by touching the screen at the top of the hyperbola as you're collecting data. You can also add point interpretations after you've finished collecting the line and are reviewing it on the display unit. Our LMX200 system has a screen we call Split View that displays the GPR cross-section and the map view at the same time. This shows the relationship of all the interpretations you've added to the data. Split View allows you to get instant confirmation that the interpretations you're adding to the cross-section is a linear feature in map view. Watch what happens as I add a point, a dot, to the hyperbola. Sorry. I mucked that one up. Let me do that one again. Watch what happens as I add a point to the top of the hyperbola. If I add a point here,